Today is day 2 of learning complete Python. Yesterday on day 1 we have completed with the variables and data types in Python. So today we are going to complete with the operators concept in Python. There are 7 operators in Python: arithmetic operator, assignment operator, relational operator, logical operator, identity operator, membership operator, and bitwise operator. Each of the operator is very important. Out from these 7 operators, there is no operator present in Python. So need to remember these. So inside arithmetic operator, we have addition, subtraction, multiplication, division, modulus, floor division, and power. Star star means raised to, like 5 to the power 2. This is how 5 star star 2 can be represented. So let's move with the arithmetic operator. I will just show you one program. This is the program for the arithmetic operator. A equals to 10, B is equals to 3 is defined, and on these two values the operations are being performed. Here A plus B is addition, A minus B is subtraction, A into B is multiplication, A divided by is division, A double divided by B is floor division, A mod B is modulus, and A star star B is power. Let's run this program. We get these values. 10, A is 10, B is 3, A plus B, that is addition, 10 plus 3 is 13. Then A minus B, that is 10 minus 3 is 7. Then A into B, that is 10 into 3 is 30. Then A divided by B, that is 10 divided by 3 is 3.333. Then A double divided by B. This is floor division. Floor division means the integer only division. It will neglect the decimal point and it will print only the integer. So 10 divided by 3 is 3.33, but this 0.33 will be ignored, only 3 will be printed. Then A mod B. A mod B means the modulus value, that is 10 mod 3. Modulus is used for printing the remainder of the particular value. So 10 mod 3, what will be the remainder in this? 1 will be the remainder, as 3 3s are 9 and 1 will be the remainder. Now here you can see A star star B means power. A is 10, B is 3, 10 to the power 3 is 1000. In this way the arithmetic operators works in Python. So these are the basic things. We have been using all of them. Just this double division and star star and modulus, these can be a little bit changed. Now the second operator is the assignment operator. Assignment operator means equal to, plus equals to, minus equal to, star equals to, divide by equals to, double divide by equals to, star star equals to. All the arithmetic operators can be used and they can be used as an assignment operator. These are the shorthand operators. Why shorthand operators? Like if you are wanting to print A is equals to 2 is given, and if you want to increment this value by 5, then what we will do? A is equals to A plus 5. But this thing can be reduced by the assignment operator by A plus equals to 5. See, this much long can be reduced to this short. How? By the use of the assignment operator. Let's see the program for the assignment operator. This is the program. A is equals to 10 is given. Now A plus equals to 5. Let's run this program first. I will just clear the earlier output. Now running this program. There is some mistake. It is showing. No, it was not a mistake. Let's see. A is equals to 10. A plus equals to 5. Means 10 plus equals to 5. It is 15. Then A minus equals to 3. Now A is 15. Remember, 15 minus 3 is equals to 12. Then A into equals to 2. Then 12 into 2 is equals to 24. Then A divided by equals to 4. 24 divided by equals to 4 means 6. 24 divided by 6. A double divide equal to 2. This is the integer only division or the floor division. 6 double divide by 2 means 6 divided by 2 is 3. 3 is printed. Then A mod 3 equals to 3 means 3 mod 3. What is the value of 3 mod 3? Mod is used to print the remainder. The remainder is 0 in this case. So A star star 2. Now 0 to the power anything, it is 0 only. So this is how the assignment operator is completed. Now the third one is the relational operator. Relational operator, we have 6 operators, that is less than, greater than, less than equals to, greater than equals to, equal to, and not equal to. The output is in the true or false format. It will compare the value and it will print the output in the form of true and false. Let's run this program. See over here, all the output are in the form of true and false. X equals 10, y is equals to 20. Print x is greater than 20. 10 greater than 20, it is false. X is less than y, that is 10 is less than 20, it is true. Then 10 is greater than equals to 20, it is false. 10 is less than equals to 20, it is true. 10 is equal to 20, that is false. And 10 is not equal to 20, that is again true. In this way, the relational operators are there. They are used to find the relation between the two values and print the output. Now the fourth operator is logical operator. And, or, and not. These are the 3 operators inside the logical operator. They are represented by the same value, a and d, and, or, not. It in other programming languages they might be different, like and can be represented like this, or can be represented like this, not by negation kind of thing. So logical operator, they are not represented in this type. They are represented like A and D, O R N O T only. Let's see the program for the logical operators. So here A is equals to 10 and B is equals to 5. Print A is greater than 5 and B is less than 10. A is 10 and B is 5. Is 10 greater than 5? This is true. And is B is less than 10? Means 5 is less than 10. This is also true. So true and true. What we will get? True and true will be true. So A is 10 and B is 5. A is greater than 20. Is 10 greater than 20? It is false. And is 5 less than 10? It is true. But the operator is OR. For OR operator, we need either of the value to be true. All of the value need not to be true for our operator. So 1 is true. That's why we get the output as true. Print not A equal to 10. A is 10 and here A equal to 10. So this is true. But we have been told to do the not of the value which comes inside this. So true not is false. In this way, the logical operators works. Now the fifth operator, that is the identity operator, is and is not. It shows that the particular thing belongs to or not belongs to. Let's run this program. A equals to 1020, B is equals to A, C is equals to 1020. Print A is B, means A is 1020, B is equals to A, means A and B are the same. So A is B is true value. Basically, it shows the identity operator, means compares two values and they are same or not is been seen through this identity operator. So print A is C, is A is equals to 1020 and C is equals to 2020. A is C, it is showing false. So why it is showing false? Now we need to know that A is equals to 2020, C is equals to 2020. So the list is same to same, 1020, 1020. So we must think that A must be equals to C. But it is not like that, because A is a separate container and C is a separate container. Inside Python, this list is defined with the container name. A is a separate name and C is a separate name. Yes, inside of the A and C, the values are same, but the containers are different. A is one container, C is one container. These containers can not be the same. Inside the container, the values can be the same, but these two containers cannot be the same. And that's why it is showing false. But now, how come B is equals to A is true? So B is not having any kind of list. B is pointing to the A list only. That's why B is equals to B is A is true and B is and A is C is false and A is not C, that is true. In this way, the identity operator is done. Now the sixth operator, that is the membership operator, in and not in. It is used to find whether the values are in that particular thing or not in that particular thing. Here nums equals to 10, 20 and 30. Print 20 in nums. Is 20 present in nums? Yes, it will print true. Print 50 in nums. Is 50 present in nums? No, it will print false. Print 40 not in nums. 40 not in nums. Is 40 present in nums? No, it is not present. That's why it is showing for true. Now text is equals to Python. Print P in text. Is P present in this text? Yes, P is present. So it will show true. In this way, the membership operator is completed. Now our seventh operator and the last operator, that is the bitwise operator. Here there are 6 different types of bitwise operator. These operates on the bitwise value, that is 0 and 1 values, not on the numbers. All these values operate on the normal numbers, but this bitwise operator operates only on the bits values, that is 0 and 1. What comes inside the bitwise value? First one is AND. It is represented by this ampersand type of AND. Then the OR, then XOR, then negation, then left shift and right shift. Let's see the bitwise operator more clearly. Here you can see A is equals to 5. How can 5 be defined? In bit terms, it can be defined as 0101. So I hope you know the bit values, how to calculate the bit values, like this is 1, 2, 4, 8. So this bit represents the value 1, this bit represents the value 2, this bit represents 4, this bit represents 8. So how can we write the value of 5? So how can 5 be represented? 5 can be represented by 4 plus 1. So this is 1, the rest are 0. So in this way, 0101 is used to represent the 5. How can 3 be represented? 2 plus 1 can be 3. So these two are 1, 1. All the rest are 0, 0. In this way, the 3 can be represented. And then the operation on this bit value is been performed. And then the output is shown. So here, print A and B, A or B, A XOR B, A negation B, A left shift B, and A right shift B. So I have shown here with an example: A equals to 5, B is equals to 3. These are the bit values of A and B. for 5 0 1 0 1, for 3 0 0 1 1. Now print A and B. How does this AND works? Here A is equals to 0 1 0 1, B is equals to 0 0 1 1. For AND, both the values needed to be 1 for the output to be 1. So 1 and 1, 1, 1 and 0 and 1, 0, 1 and 0, 0, 0 and 0, 0. So what is this value? It is showing 1 at this place only. So the value is 1. So output for this will be 1. So print A XOR B. A or B, this is OR. So print A or B. For OR, what we need is one of the values needed to be 1 for the output to be 1. So 1 and 1 or 1, it is 1. 0 and 1, 1. 1 and 0, 1. 0, 0, 0. So what is this 1, 1, 1? So this is 4, this is 2, this is 1, 4 plus 2 plus 1, that is 7. So the output for OR operation will be 7. So the third operation is XOR. XOR means if both the input values are same, then the output will be 0. If the both input values are different, not the same, then the output will be 1. Here 1 and 1 is 0, 0 and 1 is 1, 1 and 0 is 1, 0 and 0 is again 0. Means the input values, if they are same, the output will be 0. And if the input values are different, then the output will be 1. So 1 1 0, what is this? This is 4 and this is 2. 4 plus 2 is 6. So for this XOR operation, the output will be 6. So print A negation. So print negation of A, that is not of A, that is negation of A means how do we find the negation of a value? So for finding the negation of a value, we have the formula. If negation of A is been asked, then it is equals to minus of A plus 1. So negation of 5 is equals to minus of into bracket 5 plus 1, that is minus of 6. So for this negation of A, the output will be minus 6. So print A left shift by 1. Left shift and right shift. This is a very simple concept you need to know. Here A is given 0 1 0 1. Left shift means towards the, this is left and this is right, means towards the left we will move all the values by one place. So this one moved by one place to left, this 0 moved by one place to left, one place to left, one place to left, and inside of this 0 is written. So now finally we get the value. Then we will find out this is 1 2 4 8. So 8 plus 2, that is 10. 10 is the output in this case. Now A right shift by 1. Right shift by 1, it is similar to the left shift, just shifting the values one place by the right. So 0 1 0 1, when shifted to the right, this 1, it gets to the shifted to the right, but values are till here only. So 1 is been exited or cut down from the program. This 0 in place of this 1, this 1 over here, this 0 over here, and then 0. So what is this value? 1 0 1 0 is 2. So the output for this will be 2. In this way the bitwise operations works. Let's see the program for the bitwise operations. So A is 5, B is 3, the same to same program that we have seen just now. A and B, that is 1. So here what we value got? We got 1 only. So A or B, that is 7. A XOR B, that is 6. A negation of A, print negation of A, that is minus 6. Print A left shift by 1, that is 10, and print A right shift by 1, that is 2. In this way we have completed the second day in Python with the concept of operators. So stay tuned for tomorrow's lecture.